Hello, this is David Mukai. I'm your instructor for cae and cae4260 structural concrete. I happen to be at the Tokyo Institute of Technology. I'm going to miss the first week of class, so I'm recording my lectures. This first 13 minutes of lecture is going to be a little rough. I recorded the voiceover of the PowerPoint slides on my iPad and marked it up. And now I'm going to play it back from my iPad through my computer onto Zoom. And the audio is a little funny when I do that. Hopefully subsequent recordings will be better than this. So I'm going to go share that right now. Just a second. Okay, just a minute. Tab screen monitoring. There we go. Okay, so I'm going to play this back and you can hear what I recorded earlier. Well, welcome to Architectural and Civil Engineering 4260 Structural Concrete Design. I'm sorry I can't be there for lecture. As I explained in the notes or the announcements, I am in Tokyo at the Tokyo Institute of Technology, where I'm working on some projects for the upcoming World Congress of Earthquake Engineering. Happens every 4 years, and in this cycle it happens in Japan. So my colleague is submitting 10 papers to the conference, and I'm helping with those papers. Anyway, on the first day of class, what I typically go over is introduce the subject of structural concrete, specifically reinforced concrete to you, and I go over the syllabus. We'll do the syllabus later in a separate video. So right now, let's just talk about why you would want to study concrete structures, even if you're not going to be a structural engineer or not majoring in structural engineering. So concrete matters no matter what your specialty within civil engineering is. If you're interested in water resources, you have these sorts of water control structures there, things like dams, spillways, that sort of thing. And if you're interested in transportation, there's bridges like this or monorails like that. Okay, so here's a monorail. And if you're into geotechnical engineering, here we see some kind of erosion control structure, and often those things are made out of concrete. And if you're environmental, there's the environmental aspect of all the concrete construction, and any of the environmental structures, they use housing that has foundations made out of concrete. And of course, if you're in structural engineering, concrete is involved in almost every building. Even steel buildings have concrete foundations. And if you are specializing in materials engineering, or if you took the 3210 class last semester or the semester before that, concrete is a widely used material in civil engineering. If you are in our new construction management program, I guess you wouldn't be taking this class, but if you're thinking of getting a minor in that, concrete is a very, very important material in all construction projects. And if you are in architectural engineering, of course, there's a structural aspect of it. But the design part of that, there are many unique structures, as we'll see later, that are made out of concrete. So these next few slides are for projects around the world made out of concrete. And so here's a picture from Caracas, Venezuela. And of course you see this open channel here, and that's made out of concrete. Here's a retaining wall. That's made out of reinforced concrete. And all over the skyline here, you see buildings, and often these buildings are made out of RC. I don't know if these buildings themselves are. This is a picture of the Quay, Q-U-A-Y, or Bay concrete structure. It's the Sydney Opera House. And if you ever visit Sydney, Australia, that's a must-see place. And here are some pictures of the industrial ring road in Bangkok, Thailand, under construction. Let me paste in a finished picture. There we go. Give you an idea how amazing this road is. Again, made out of reinforced concrete. This is Tacoma, Washington, just south of Seattle, Washington. There's a reinforced concrete building here. Oh, there we go. There's an RC building. And Tacoma is home of Concrete Tech, and they are a precast plant, and they make some very innovative concrete products there. These are seismic moment resisting frames. And so when you make a building, you can make it resistant to side sway with the concrete building one of two ways. You can put in shear walls, so you can fill these things with walls. Okay. Maybe like that. So one of the bays filled with walls, and that will stop it from moving over. Or you can make the building a frame, and you have to make all these connections here at the joints very rigid so that it doesn't fall over in an earthquake. And this is called a moment resisting frame. And so this is of particular interest to me for a couple of reasons. One, whenever you read about people dying in an earthquake, almost always a reinforced concrete frame building collapse. They're really the people killers in earthquakes. I've done reconnaissance of the Christchurch earthquake, and a lot of the research I'm doing here at Tokyo Tech is all centered around moment-resistant concrete structures, not necessarily moment frames, but all sorts of things, and I'll talk about those things when I get back. Another reason this is of interest to me, the first moment-resistant concrete frame built in the U.S. was actually designed by University of Wyoming graduate. His name was Wayman Ching. I'll find out his name. It's back in the office when I get back home. I have the poster for that, and we'll talk about that too when I get back. But anyway, these are seismic moment resisting frames made out of reinforced concrete. So this is another building in Tacoma, Washington. It has a soft first floor, and ideally, the thought is it would isolate the upper parts of the building from an earthquake. This is maybe not such a good strategy anymore. We can talk a lot about seismic performance of concrete buildings when I get back. This is exactly the sort of thing I'm looking at right now here in Tokyo. This is the museum in Washington, D.C., a museum about newspapers. Ironically, it just closed last year, but this building was famous because it had large clear spans, and this construction technique here, you see these slabs, see how they're flat? This is flat plate construction. And it's flat, oh, right here, it says flat slab post-tension construction. If you take the previous concrete course, we talk about how to design these types of floors. This is a very cool church at St. John's College, and this structure here is very interesting. Made out of reinforced concrete. It's this flat plate here, held up by this reinforced concrete base. This type of construction illustrates one of the flexibilities of concrete. You can form it and make it any shape you want out of it. So this looks like brick, but it's not brick. This is precast concrete made to look like brick. And you can make panels that look like brick, but made out of concrete. And the reason you would do that is that you get actually have very thin bricks, so this might actually be 8-inch brick that's been embedded into concrete, or it just might be colored concrete, maybe like brick. But in any case, you would make these panels at a precast plant, and you can truck them in and just put it up, and not have to have masons there the whole time. Also, you don't have to have a massive storage yard with all the bricks while you put it up. This is especially convenient in dense urban areas. Here are two monorails. I'm almost certain I got these pictures from Charlie Dolan, the author of our book. He's the world's expert on monorail design. So he designed both of these monorails. He did Disney World monorail when he worked for ABAM Engineering in Seattle. And that was before he came to University of Wyoming. And later on, when they built this Dubai monorail, they called him because he's the world expert on monorail design, and he did that. He even had a design class for freshmen that centered around building monorails once. One of the cool things about getting around in Tokyo are the trains. The trains are amazing. We can talk about that when I get back. Here's a train line in Washington, D.C., Metro. And these trains go underground, and these tunnel liners here are made of cast in place concrete. And showing flexibility of concrete, you can form it to whatever shape you want. Here's an aerial view of the Dallas-Fort Worth Airport, and you can see all these on-ramps and off-ramps here, like this, these clover leaves. Those are all made out of reinforced concrete. This is an interesting structure. It's a pier that floats. So you would put it next to the shore, and there's a bridge from the shore onto the pier that goes up and down with the tide. This bridge was probably cast at a plant, and they're transporting it to its final destination with a tugboat. Here's a drilled shaft foundation for the geotechs. You drill this giant hole, you put a rebar cage down in there, and you would fill it up with concrete. These are precast concrete piles. They're made at a plant, and then you deliver them to the site, and you hammer them into the ground. A couple of the papers I'm working on now have to do with seismic performance of concrete piles that have steel casing on them in earthquakes. Turns out these piles are shearing in large earthquakes. They just shear off. In transportation, these type of tent structures here that hold up overpasses and bridges are often made out of reinforced concrete. Particular concern about the durability of these things, and the bad thing with reinforced concrete is if the steel rusts, steel that's in the concrete, then the rust expands about 10 times the volume of the steel. And when it expands, it can pop the concrete off. So to avoid that, there's a project where they're using fiberglass reinforcement. Part of the problem with fiberglass reinforcement is that it's hard for concrete to grip the fiberglass reinforcement. We'll talk more about that when we get to development length. I'm not like this, but often concrete people and steel people, they have good-natured fun at each other. I just think there are different materials for different applications. But here's a picture making fun of steel workers out to lunch. Of course, this is an iconic picture of these steel workers having lunch, sitting on this beam high above New York City. So as you go through your schooling, I want you to think about where you're going and what you'll do, and maybe reinforced concrete will be part of your future.
Okay, so that was a brief introduction to the types of reinforced concrete structures. Next, I'll go over the syllabus, and then I'll have a lecture about what exactly is reinforced concrete. But I'll end this for now, and hopefully this will get uploaded to YouTube.